So in this video we're going to practice algebraic equations using rearranging the equation and simplifying to solve for x. So let's start by taking a crossing point of two of these functions. So we'll just look at the crossing point here. And when y equals 5, these two functions are simultaneous equations. So if y equals 5 for both of those functions, then we must have, and we'll call it problem 1, 2x plus 1 must equal x plus 3. Okay, so that gives us problem 1. And we're going to go through all the crossing points of these functions to give us, well, what looks like, I think, 9 problems that we're going to solve for x. So we'll call this problem 1. And let's give it a go. So, various ways of solving these things, but if we subtract x from both sides, we'll end up with 2x minus x on the left-hand side, in other words, just x, and eliminate the x from the other side, so x minus x is 0, 0 plus 3, just 3 then. Now we subtract 1 from both sides, giving us x on the left-hand side. 3 minus 1 is 2, so x equals 2. Now it's a good idea to check our result. So if we substitute x equals 2 back into the left-hand side of the equation, we get 2 times 2 equals 4. 4 plus 1 equals 5. And on the right-hand side, x equals 2 plus 3. 2 plus 3 equals 5. So 5 equals 5. So it's a really good idea to do that check so that we can be confident that our answer is correct. Okay, let's look at crossing point number 2. And I think what we'll do is come down here and look at these two functions here. So that gives us the problem x plus 3, this time equal to half x plus 2. So if you're confident, good idea to pause the video at this point and give it a go. Okay, so I think what I'll want to do here is eliminate this half x, so I'm going to do that straight away. So if I subtract half x from both sides, I'll end up with x minus half x, in other words, half x on the left-hand side, plus 3 equals half x minus half x eliminates the half x, so just 2. And now if I subtract 3 from both sides, I've got half x equals 2 minus 3 minus 1. Now to get rid of the half, I simply need to multiply both sides by 2. 2 times a half will give me just 1, so 1x, in other words just x. And 2 times minus 1 gives me minus 2. And we can see on the graph, in fact, that x equals minus 2 is the answer that we would expect. And if we substitute back in to the left-hand side of the expression, minus 2 plus 3 gives me 1 on the left-hand side. On the right-hand side, minus a half times minus 2 will give me minus 1 plus 2 gives me 1 as well. So I've got 1 on both sides, therefore x equals minus 2 must be correct. Great, okay, let's move on to problem 3. Now, where are we going to go next? Let's deal with this one here and call this problem 3. So what have we got? For problem 3, we've got x minus 1 equals half x plus 2. Okay. So again, I could eliminate the half x by subtracting, just as we did in the previous problem, but I'm going to do it slightly differently this time. I'm going to subtract the whole of half x plus 2. In other words, I'm going to put the equation equal to 0. So if I simply rewrite this x minus half x and minus the 2 minus 1, then I've eliminated the whole of my right hand side, in other words half x plus 2 minus half x plus 2 equals 0. Now, I just gather like terms, so I've got x minus half x giving me half x. Minus 2 minus 3 gives me minus 2 minus 1 gives me minus 3 equals 0. And whenever you've got this arrangement, in fact, you can almost immediately say, or immediately, you can skip a step and say, well, half x must equal 3, because if I add 3 to both sides, I'm going to get half x plus 3 minus 3 eliminates the minus 3, and 0 plus 3 gives me 3. Therefore, x must equal, we'll multiply both sides by 2, so that x must equal 6. Let's substitute back just to check. 6 minus 1 is 5. On the right hand side, half of 6 is 3 plus 2 is also 5, so x equals 6 must be correct. Okay, on to problem 4. And let's go down here. So what have we got? 2x plus 1 is the first function, and the second one is x minus 1. Now, if you haven't paused the video up to now, this would be a really good one to make your first attempt. Okay, so we're going to subtract x from both sides, and we're going to subtract 1 from both sides as well. So 2x minus x will give us just x plus 1 equals minus 1. And now to subtract the minus 1 from both sides, x plus 1 minus 1 equals 0, so just leaving x. Minus 1 gives us minus 2. And that was exactly what we were expecting, because again from the graph, if we read off the x value, we can read it off as x equals minus 2. Okay, substituting back then to check, 2 times minus 2 is minus 4, plus 1 is minus 3, so minus 3 on the left hand side, and on the right hand side x equals minus 2, so minus 2 minus 1 is also minus 3. Okay, so that's problem 4. Now, the problems that we've got left are in the middle. Let's try this one first, so we'll call that problem 5. Okay, so what have we got? So for problem 5, we've got x minus 1 again. Perhaps let's put that on the right hand side this time. Well, this time we've got our backwards sloping function, so we've got y equals minus 2x plus 2. And so it's a negative coefficient, so no problem, we just write that down. Minus 2x plus 2 is equal to x minus 1. Okay, so how are we going to deal with this? Well, there are a number of ways of dealing with this. We certainly want to get rid of this coefficient. We want x to appear on the left hand side. Let's try then, perhaps if we subtract x from both sides to start with, or we could start with the numbers. So let's start with the numbers, in fact. So we want the numbers to appear on the right hand side. This is how we're going to tackle this one. So I want to eliminate this. So I'm going to subtract 2 from both sides, leaving us with minus 2x equals 2 minus 2 equals 0. So that's eliminated that. So minus 2 on the right hand side gives us x minus 1 minus 2, x minus 3. Okay, now we want to get this x eliminated from the right hand side, so we need to subtract x. So we subtract x from both sides, giving us minus 2x minus x minus 3x equals minus 3. Now what we can do is we can divide through by minus 3. So divide both sides by minus 3, giving us x equals minus 3 divided by minus 3, x equals 1. Okay, let's substitute back. Minus 2 times 1 is minus 2 plus 2, so 0 on the left hand side. On the right hand side, x equals 1. 1 minus 1 is also 0, so that must be correct. Okay, now I think they're going to get a little trickier. Let's try this one here. Okay, so we'll call this problem 6. And so we're still dealing with this negative backward sloping function, but we've got a very straightforward x plus 3 to start with. So let's start with that. Okay, so problem 6, whoops, let's make that clear. Problem 6 is x plus 3 equal to minus 2x plus 2. So you might want to pause the video and give that one a go. Okay, so I'm just going to straight away get rid of this minus 2x by adding 2x to both sides. So we've got x plus 2x giving us 3x plus 3 on the left hand side, and that eliminates, that's minus 2x, leaving us just with 2. So 3x plus 3 minus 3, and then we'll subtract 3 from the other side as well, gives us 3x equals 2 minus 3 minus 1. Therefore, if we divide through again by 3, like we did last time, we'll end up with 3x divided by 3 gives us just x, and on the right hand side, minus 1 divided by 3 is minus a third. Okay, checking this out, we've got 3 minus a third, that's going to be 2 2/3. And here we've got minus 2 times minus a third is is plus 2/3 plus 2, 2 2/3. So 2 2/3 on both sides, so this must be correct. Okay, and in fact, if we read off from the graph, we can see this does look very plausibly like minus a third. Problem 7. Now, we're running out of problems, so we've got to go in the middle somehow. Let's pick off this one here. So it's really difficult to read off the graph, so we'll have to trust our algebra. Okay, so what have we got? We've got 2x plus 1. 2x plus 1 equal to, let's just mark this problem 7 so we don't get confused. So let's write that here, 7. Okay, what were we saying? 2x plus 1 equals half x plus 2. Half x plus 2. So there we go. Okay, how are we going to deal with this? Well, I think straightforwardly, let's just move the numbers to start with. 2x, subtract 1 from both sides, equals then half x plus 2 minus 1 gives us plus 1. Now it gets a little bit interesting here because if we remove this half x, we're going to subtract that from 2x on the left hand side, which will give us a fractional coefficient. Not a problem, but I think what I'm going to do before I do that is just change this 2 multiplier to 4 divided by 2, in other words 4 halves. And you can, I'm sure, see why I want to do that, because what it's going to give me is a common denominator. Okay, let's go ahead and subtract a half x from both sides now. So we've got 4 halves of x, let's write this out fully, subtract a half x on the left hand side. That eliminates the half x here, and we've just got 4 halves of x minus a half of x equals 1. Now 4 halves minus a half is going to give us 3 halves. So what have we got? 3 halves of x equals 1. If we multiply now by 2/3, that will immediately give us, it will eliminate the 3 over 2 on the left hand side, giving us therefore x equals, well, 1 times 2/3, so just 2/3. So that's problem number 7 dealt with, but let's just check. So 2 times 2/3 gives us 4/3. I might just write this out because the fractions are getting a little bit complicated here and we don't want to get lost. So let's see. So we've got 2 times, so we've got 4/3 on the left-hand side, plus 1, well, plus 3/3 then. And on the right-hand side, we've got half. We've got half of 2/3, so we can write that as 2/6, so 2/6, plus then 12/6, so 2 equals 12/6. So we've got thirds and sixths. Let's see what happens when we combine them. 4/3 plus 3/3 is going to give us 7/3 on the left-hand side, and 7/3 equals 14/6, because that simplifies to 7/3. Okay, so a little bit of calculation there just to do our check, but well worth doing, because we can now be certain that this must be correct. And if we look over onto the graph, well, that does plausibly look like x equals 2/3. Okay, so let's just erase our working to give us enough room, and finish with a couple of hopefully not too difficult problems that we find in the center here. Okay, so what have we got? Let's tackle this one here first. So that's problem 8. So problem 8 is going to give us 2x plus 1 equal to, what have we got? Okay, it's this backward sloping function again, minus 2x plus 2. So pause the video if you want to give that a go. I'm just going to erase my 8 here, just make that a little bit clearer. Okay, before we attempt this. So how would I deal with this? Well, let's eliminate this minus 2x. So add 2x to both sides gives us 4x plus 1 equals 2. And now we want to eliminate the 1, so we have 4x, subtract 1 from both sides, gives us 2, subtract 1, gives us 4x equals, I was going to say 3, I must be getting very tired. 2 minus 1 gives us 1, so I'm just going to write it like this, and let's just erase that. 2 minus 1 gives us just 1. Okay, and then if we divide through by 4 on both sides, we'll have 4x divided by 4. That will eliminate that 4. We just have x equals 1 divided by 4, or 1/4. And looking at my graph, again, that does look plausibly like x equals 1/4. So let's just do our check though. 2/4 is going to be a half, so half plus a 1, 1.5. And here we've got minus 2/4. So that's minus a half, so 2 minus a half gives us 1.5. So 1.5 on both sides, x equals 1/4 or 1/4 must be correct. Now, our final one, and you really must try this one because this is going to be an interesting one, which is why I've left it till last. We'll define as problem 9. So right in there. And problem 9 should give us an answer. I can see already x equals 0, because if I read down, we're right on the y-axis here, so x equals 0. Let's see if it does. So what are the functions that we've got? We've got half x plus 2, half x plus 2 equal to minus 2x plus 2, minus 2x plus 2. So again, pause the video and see if you can solve for x. Okay, so this is an interesting one, and I think because it's slightly unusual, I'm going to try the method of bringing everything over to the left-hand side and putting the equation equal to 0. So if I bring this over to the left-hand side, I'm going to add 2x to both sides, because if I subtract, well, I'm adding 2x to both sides, so I'm going to, I'm just pausing here because I'm thinking, and what I'm thinking is, if what I could do is combine two steps here. If I think of this as half, in terms of halves. So let's just do that to start with. So rather than just going ahead, let's just think about this before we plunge right in. Okay. So minus 2x is the same as minus 4 halves of x. It's just a little modification that I've made, which is going to make my life a little bit easier, especially since I'm running out of room. Okay, so now I'm going to think of, to eliminate this from the left-hand side, adding 4 halves of x. So I'll end up here with 5 halves of x. Okay, 5 halves of x on the left-hand side, plus 2, plus 2 equals 2. Okay, so I thought this might get interesting. And here we've got, we want to eliminate our 2, so I'm going to subtract 2 from both sides. So here we've got a very interesting situation. If I subtract 2 from this side, I'm going to eliminate the 2. If I subtract 2 from this side, I'm going to eliminate the 2 as well. So in other words, what I've got, I'll write it over here so that we don't get too squashed up. We've got 5 halves of x equals 0. Now, how do we deal with that? Well, we can just think of this as a fraction. We can multiply through by 2/5, so whatever we got on the right-hand side is also multiplied by 2/5. We could split it up, but the point is that on the right-hand side we've got 0. So whatever's going to happen, x is going to equal 0. Because, well, if I just think of 0 times 2/5, okay, and delete, then this on the left hand side, 0 times 2/5, well, 0 times anything will equal 0, so x must equal 0. Okay, therefore x equals 0. So a little bit of an odd one to finish, but no problem. X equals 0, which is what we're expecting. Double check our answer. Half times 0 is 0, plus 2, so we get 2 on the left-hand side, minus 4 over 2 times 0 is 0, plus 2, so again we've got 2. So this must be correct. Okay, now that finishes our 9 problems, and I hope that was successful for you and you managed to do some of those. Maybe you found some methods that were different to the worked solutions, and that's good. The final thing I want to say is, what if we had this? So let's have problem 10. Let's write it down here. What if we had x plus 3 equals, let's see, yeah, x plus 3 equals x minus 1. So what I'm doing is I'm looking at these two lines here, and I can see that they're parallel. And they're parallel because the coefficient of x on both these functions, so we've got f of x and I of x, are exactly the same. In other words, 1. So they're both 45-degree angles. So the coefficients are exactly the same. That means the slope, the gradient must be the same. And it means we've got parallel lines which don't cross. And so if we've got that situation, then this is unresolvable. In other words, there's no value of x that we can substitute in here that will form an equation. And this is illustrated in the graph by the parallel lines, which clearly are never going to cross. So we have to say that on this occasion, problem 10, this problem is unsolvable using conventional mathematics, and so as long as we state that, that should be correct. Okay, so really you're going to get this sort of situation happening only very occasionally, but if you do, you should look out for it, that if we have the x terms, the coefficients of x on both sides as being exactly the same, then it's not going to be solvable, because you're just going to eliminate x entirely, and so you're not going to be able to arrive at an answer. So don't get confused by that. Apart from that, you can really invent any, as long as the x terms are different, have different coefficients, you can invent your own and easily develop your own worksheet to do some further practice. So I hope this video has been helpful. I hope it's been quite enjoyable working through with this graph and looking at the crossing points. And please do practice some more. Make sure you're absolutely fluent with rearranging equations and solving for x.